You may have You may have some functional testing to test the business requirements of a service, like the specific result is being achieved by that function or that method. End-to-end tests, of course, test the entire spectrum of your application from one end to the other. You may have acceptance testing that are doing the same as the end-to-end test, but for the business requirements. Does the result happen that I think should happen in this method? Am I accomplishing the spec that the business requires of me? And of course, you will probably also have some smoke tests, which are some basic testing around, like, is this link blue? Is this text in the right font? Is this H2 tag rendering correctly? Things like that. Synthetics testing, in addition to that whole layer of testing suite, which is essential and important, adds another layer to that dimension. What does synthetics monitoring do for you? So synthetics monitoring simulates the user experience through an application in all the ways a user is going to use that app, and also all the ways a user is going to use it in ways you don't expect. So all the ways you expect a user to use it, and all the ways that users may use it with, when you have no assumption that a user is going to do that, what they're going to go on that, and they're going to do that, and suddenly they come to an error page because you never anticipated that. So for example, if you're on the Google homepage, synthetics monitoring to begin with might check, well, what happens if I click that button and just click it right off the go? What does it do for me? What happens if I hit return on an empty search bar without any text in there? And those links on the top right hand on the navigation bar, do they work? Where do they take me to? And that's just the beginning of what you can do on this Google homepage. There's a whole other array of stuff you can test, and test all the different user paths. It almost involves a little bit of human psychology when navigating through your website with an aim of building synthetics monitoring. There are synthetics automation tools out there. There are companies and services that will do this for you, will automate it for you and make it really easy for you to get going. I would be remiss if I didn't mention New Relic, as they are the ones that pay my salary, and I think they're quite awesome, if I'm honest. They, of course, have their own synthetics monitoring suite as part of their New Relic One, which is an all-comprehensive observability and monitoring platform. These are some screenshots from New Relic One, and this, by the way, is a screenshot of, I just took a few minutes ago, of the sample site that we will be using for our workshop of a ping test. So I built a ping test on New Relic One, and I had it ping the site from multiple locations in Asia and Europe and the Americas. And I got back the ping results, and I have that set it to run on a schedule of every 15 minutes. So the site is constantly getting pinged from around the world, and that data is being fed into that dashboard. And if there's any anomalous behavior, I can configure alerts to let me know that maybe the throughput is a little slower, the lag on the website's a little slow, or it's not responding on one server somewhere in one region of the world. So that's all awesome. But it's great to have automation tools. But sometimes it's fun to build these things ourselves, because, automation makes it look easy. Automation, we fill in a few buttons, click a few buttons, fill in a few forms, and it's off and running. But what's happening behind the magic? What's happening under the hood? Well, that is what we're going to do together now when we build our own automation, synthetic monitoring automation suite. I want to first start by prefacing where we will begin this conversation, this workshop in. What we will learn together and what we will not learn together. What is the base assumption of where we are starting from? Because I think that's really important. When we are learning together in a workshop, we cannot possibly cover everything on the topic of everything, of all the things. So we have to frame where we are beginning from, so all of you who are joining us will know what our starting point is. So what we are not going to be learning together in this workshop is things like JavaScript syntax, the async await pattern, using a terminal, interacting with Git. We are going to assume that knowledge to be able to function in this workshop. What we will learn together are things like the Selenium WebDriver, the Selenium node package, navigating DOM with Selenium, and using GitHub Actions to automate that navigation and that interaction. So I think that's important to start off with that framing, but I want you not to be worried, because every exercise we do, if you think to yourself, so I don't really know the async await pattern so well in JavaScript, or my JavaScript syntax is a little rusty, I don't really know what I'm doing there, I'm a little nervous. Don't worry, don't fret. Every exercise we do together in this workshop will be done in small groups so no matter what, you'll probably have someone in your group who can help you in the areas that you are feeling a little rusty in, and perhaps you can help them in areas where they are feeling a little rusty, and we will lean in on each other and we'll do a great job together. So let's explore the Selenium WebDriver. And by the way, if you have any questions at any point in this introductory phase, as we're building up to the actual challenges, please post them in the chat here on Zoom and let me know, and I'll do my best to answer them. I am by far not an expert in anything, but I'm interested in a lot of things and happy to share. And if I don't know, I'm also not nervous to say I don't know, and we can look it up together, or we can look it up offline asynchronously later. So what we will do together is we're going to start exploring Selenium WebDriver. Selenium WebDriver is a language agnostic set of tools that allows us to drive a browser, right? WebDriver, drive a browser natively, as in we can interact with a website as if we were a person sitting in front of our computer at our keyboard and our mouse and using the website, but we are not a person. We are a piece of code that will pretend to be a person and do what it needs to do and what we told it to do. So the ways in which we will interact with the website as a person are the ways in which Selenium WebDriver empowers us to do that in our code. We can locate elements, we can click on elements, we can enter text, we can clear text from text fields, we can submit forms, we can select from lists on web pages, and that's just the tip of the iceberg of the things that we can do with Selenium WebDriver. So we can really do the full array of actions as a person can do on a website, but as a program, as a code that you've built to automate and roboticize it for you. So you may be asking yourself at this point, how do we interact with a website without the browser, right? Like, when I'm going to a website as a person and I'm at my computer and I, click on the URL bar and I type in a website and I click enter or hit the return key and the website loads, I know I can use my mouse or I can navigate with the keys to get to where I want to go. But how do I, for example, on this weather.com page, which by the way, this is the weather for around the London area right now, it looks quite nice. In the afternoon, it's about 19 degrees. That's lovely. Great weather today in London. So how do we navigate, for example, to that search bar at the top of weather.com? How do we do that when we're not actually there? How do we tell our code to do that? That is a big question, and I would not be surprised if you're asking yourself that question right now, because that is the question we will answer. We do that by using locators in Selenium WebDriver. We find the elements with a set of classic locators, which by and large cover all the use cases we will need when navigating to certain parts of the website. There are special edge cases here, particularly with really fancy JavaScript heavy websites that do a lot of stuff on the client side, and it's what you see is not necessarily what you get, and it can get very complex. But on most cases, for most things, these locators will help you. So you can locate elements on the DOM by the class name, by the custom CSS, by the ID tag or the name tag, by a set of either partial text or the full text, by the tag, the actual HTML tag, or the XPath, which is a designation of exactly where on the DOM the element is, and you can identify it there. You may be wondering to yourself, how do you get these things? Well, you can use your browser inspect tool. If you haven't used it before, it's an amazing thing. It's a treasure. You can use the browser inspect tool to browse and inspect any website and see the CSS, see the HTML for the website, and see what is the ID, what is the name, what is the custom CSS. And in fact, browser inspect tools in all modern browsers will also give you the full XPath or the relative XPath for an element on the DOM as well. So taking one relatively simple example, let's say we were looking at this piece of HTML from a website and we wanted to navigate to either the div or the p tag inside of it. How might we do that? So take a look at that yourself for a moment. You can, we'll just take a minute before we start addressing this. What are some of the things on that little relatively simple HTML that you could use to identify the different elements? You could put them in the chat. You could say them to yourself silently, whatever you like. We're going to pause for a minute to let you think about it, and then we're going to dive into it. And I'm going to take a breath and drink some more coffee. Okay, so the places you may find and use different locators to find things on this sample HTML might be the tags. So you have a div tag and a p tag, and you can use Selenium WebDriver to identify the elements by those tags. You also have things like the ID. So you can use the ID names to find the div awesome ID or the ID of my text here for the p tag. You also have the name here. So for the div, it also has a name, awesome name. You can use the awesome name to find that div on the DOM. And you also have the classes. So you have awesome class and open text, and you can identify either and locate and grab the div or the p within by using the class name. And you also have the text itself inside, contained within the p tag, which is Hello City.js. Any one of those things can help you locate this body of HTML from the website. Now, what's important, when you hit the div, you're also going to get the things nested within the div as well. You'll get the p tag too, which is very interesting and something to really keep in mind as you start building through all of this. Well, what does it look like to actually use the Selenium WebDriver node package, NPM package, to actually build a synthetic test, a synthetic monitor? So this is example code that comes directly from the documentation from NPM. And let's just walk through a few key elements here because it's, I think, very pivotal as we go forward. So first of all, we're using the structured assignment to require the package, Selenium WebDriver, and we're giving it to multiple variable names, builder, by, key, and until. We declare those and we equal them to the package, to require the package. We then instantiate an instance of the builder and the driver by creating a variable called driver, and we assign to it a browser instance of Firefox. We could also put in there accept an argument of Chrome, amongst other browsers, and we build it. So now we have our driver instance, which is the browser, right? And then we're using, as throughout this, you see we're using the async await pattern, and we're doing async await because we're dealing with the websites, we're dealing with front end, which means every promise needs to get resolved. So we need to use some kind of JavaScript pattern to negotiate that promise. So we are using async await in our examples. And then what I happen to think is that the method names within the Selenium WebDriver node package, and it's true for the other languages as well, for their packages or gems or what have you, for Selenium, are quite intuitive. So if you, to get the browser, to get to the URL in the browser, use the method get, and it takes an argument of the website you want to go to. To find an element, the argument, the method name is find element, and it takes an argument of find element by what? So let's say by the name. So the name here is Q, and we're looking obviously at google.com. So we're looking for the query bar, the search bar. And then we see that there's this method called send keys, which does what it sounds like, namely that it lets you type on your, as if you're typing on a keyboard and sending something, those key presses. So we are going to send the keys that equal the word WebDriver, and then we're going to hit the return key. And if you're ever on google.com and you would hit the return key at the search bar, that is the way of initiating a search in addition to clicking on the search button. So we have started a search. And what's important here on the next line is we also then have a wait until declaration, which essentially says, wait until the new page, the DOM, has been fully initialized and loaded before you look for the thing. Because there's a little bit, again, of a race condition. If you look for it before it's loaded, before the DOM is fully initialized, you're not going to find it. So Selenium WebDriver helps address that by offering you wait until, which says wait until, and it takes two arguments. Well, it takes, the wait until takes an argument of how long. So in this case, is we're saying wait for 1,000 milliseconds, and then the title is a way of looking for and declaration as a true or false. Wait until the title is equal to, and what is the argument? WebDriver - Google search, which is the search query we put in WebDriver, and the appending to that on every Google search, they put -Google search. And then finally, we want to close this browser session, so we use the quit method to close the browser session. I think the method names here are very intuitive and very helpful, and it's almost as if you can guess the method names when you're building a function, because they're so closely coupled to what you're actually trying to do, which is kind of nice. Similarly, and furthermore, we also want to make sure that we include not only the WebDriver, but we also want to include the driver for the browser we want to use. So in this example, we're using Chrome driver. So we want to make sure we include the Chrome driver as well in our code that we're building. And I also want to draw attention to this bottom half of the red box, where the red box is highlighting for us that in the previous example, we showed how to instantiate a builder instance without any options, just a builder instance implicitly with all of its defaults. But you can actually break out those things and define all the parameters for your Chrome browser, your Chrome driver browser, or your Firefox driver browser, whatever you're using. And you can set those options explicitly and override the defaults. So for example, and this will become very important as we get later on, there is the dichotomy between using Selenium in head mode versus headless mode. In headless mode means that the browser activity is happening behind the scenes, and all you see as a user, as a developer, when you run the code is what you've told the code to output at the end for either a success or a failure. If you have headless is false, what will actually happen is a browser window will actually open on your computer, and you will watch your code interact with that website as if it was you on the browser. So that's really cool to watch, but there are instances and there are times when you want to set that to be headless to be true, and you're going to want to have that happen in the background and only output to you the results of that interaction, however you define those results to be, as opposed to watching it or actually physically manifesting a browser window and showing it to you on your monitor. Any questions up to this point? If there are any, please, you're welcome to add them here in the chat. If not, we're just going to keep on going. So example, navigating web pages, right? So get a page is takes the argument of the website, to go clicking on the back button, right? Simulating the clicking button, navigate.back, clicking the forward button, navigate.forward, refreshing the page, navigate.refresh. To locate elements, we have find element by class name as an example, find element by ID. And as I mentioned, an element can have the other elements nested within it. So we can use find element again on the variable containing the parent element to find the child element inside of it. So for example, fruits, find element by ID fruits, and then we can find the fruit by fruit.find elements, because inside fruits are now nested elements, child elements, and we can find it by ID tomatoes. We can get a list of elements, an array of elements, using find elements, so that pay attention to the singular versus the plural. So find elements gets us an array of elements, find element gets us a single element. And here's an example of how you can use in a function to get the active element on the page. So using the google.com example once more, let's say you've entered some text in the query bar and you have not hit the return key, you have not pressed the submit button. What is the active element on the DOM right now? On that last line of the code, you can go using the method switch to active element to actually have the web driver navigate to that active element, and then you can use the get attribute title to get what is the element attribute. What is the title element? What element on the page when you're on google.com and you have not yet hit the search bar, you've not yet hit the search button, but you've typed in text in the search field, what is active on that page right at that moment? That's very helpful for accessibility purposes, for example, and you can use that in console log to get the data from that active element. So now we're ready to begin. We're excited. Our moment is finally here. We're ready to get started actually building our workshop together. So I'm going to paste the link in the chat here to the repo that contains our workshop stuff. So the link is github.com/BenCGreenberg/ synthetics workshop. And what we want to do first on your machine, so please open up your terminal. We are going to clone this repo. So using git clone, we're going to clone the repo, and we're going to use, so let me actually paste that as well in here. We're going to clone the repo using the path to the repo. And once you've cloned the repo, I want you to change directory into it. Now, what's very important is that we're going to build our solutions together in the test folder of this repo, in the folder called tests. What we're not going to do is look at the examples folder right away. I know it's very tempting to do so, but we're not going to look at the examples folder right away because it contains solutions for our challenges. And I put them there intentionally, not only to tempt you, but also to offer you a way out and to give you some help if you get stuck throughout the challenges. So the sample site that we're going to use is also linked right there. I'll put in the chat as well. The sample site is express-xbdl.onrender.com. This is our site. It's about the minions because we all love the minions. And we see on this site, we have a title, some text. We have a form to subscribe with a text field and a button. And we also have 4 minions. We got Bob and Fatigue and Kevin, and we have Stuart. Bob is our founder. Fatigue is our tired specialist. Kevin is our team member, and Stuart is our HR manager. So we have a few links to navigate here. We have a form and we have some text, a lot to do with on this simple page has already a lot for us to build our tests with. So that's our page. So it's express-xbdl.onrender.com. That's where we're going to go to build off of our tests. And if you have cloned the repo and you're in it, you have already got to this first step where you're on your way towards solving the first challenge, which is setting up your machine. So you need to make sure that on your machine, you have Node.js installed and NPM, which is the Node package manager, Chrome driver, and Selenium WebDriver. You can follow that link, nodejs.org/download/package manager, to follow the instructions for your operating system. And then, for example, in a Mac OS context, in the terminal, you can use Homebrew to install Chrome driver with brew install Chrome driver. And once you have the Node package manager installed, you can use it to install the Selenium WebDriver, npm install Selenium WebDriver. So let's just take a few minutes now to make sure that you are up and running on that, Edmar and Helene. Let's just make sure you are up and running with Chrome driver and Selenium WebDriver. And you'll know it's working by once you have finished everything. If you can do the following command in your terminal, Chrome driver -- version, that should output to you the version of the Chrome driver you installed, which will be the latest stable release version. And if you don't have that, that means something went wrong in your installation of the Chrome driver, which is essential for us. And we're using that as the test case of whether we have everything set up correctly. So let's just take 5 or so minutes now to make sure this is set up and running correctly. So install, if you don't have already, Node, Chrome driver, and Selenium WebDriver on your machine before we move forward. This is really, really essential. So I am going to let that happen, take some time, and we'll come back and make sure it's working for you all. If you have any questions in that process, please make sure to ask in the chat, and we will hopefully be able to help you resolve them. While we wait for another couple minutes, I'll give you some music just to pass the time to make sure you're up and running.
I'm here, 1 second. There are only 2 people though.
Right. So maybe we'll just do it here. Let's just do it here.
Yeah.
Okay, great. Okay, so we are not going to break out into rooms. We're going to do it together. It's going to be more fun. So we are going to do the first test together. Edmar, I hope you're ready for this. It's going to be awesome. You can unmute yourself if you're able to. Are people able to unmute themselves, Aris?
Yeah, that's cool.
Okay, great. So we're going to let you unmute yourself, and we're going to do the ping challenge, which is to check if your app is actually alive. So we're going to build a synthetic test to check if the application responds to a ping request. That is what we're going to do for now. What I want to do is actually, I'm going to open, you should be seeing my terminal. What I want to do is open my code browser, VS Code. Great. Okay, so what we are going to do is we are going to build our ping test, which is what we're going to, as we said in, let me go back to that for a second. Is the app alive? We're going to build a synthetic test to check if the application responds to a ping request. And we're going to output a success message if it's alive and output an error message if it's not. This is the challenge in front of us. This is what we're going to build. Helene, Edmar, Aris as well, you're welcome to join us in doing this as we build this together. If that makes sense for everyone, it's going to be awesome and exciting. So let's load the file. I'm going to make this bigger. Hopefully that's easier to see for everyone.
Yep.
Great. Yeah, okay. So we're going to test the websites available. So if you remember, the first thing we need to do, and let me also paste the link in here. So this is the website. That's the website. And all this test is checking is, does this website, does it respond? Is it alive? Or does it not respond? Does it not render? Does not load? That's essentially the test. That's what we're going to call the ping test. So the first step, I'll give it away. We need to actually use, as we mentioned, assignment destructure assignment to require the WebDriver. So something like this.
Ben,
Yes.
I think you're not sharing you're sharing the other screen.
Oh, okay. Let me share again. Thank you, Aris. That's very helpful. Okay, I'm going to share again.
And maybe start when you start showing the code, because we didn't see that.
Okay, you should see this now. Do you see this?
Yeah. That's perfect.
Okay, great. So I'm looking in my VS Code window, and I have started us on the test, which is in the comment, we want the test that the website is available, right? That's what we're calling the ping test. And this is the website we're going to, express-xbdl.onrender.com. And I've already got us going by starting to require the Selenium WebDriver package by destructured assignment. And we need some variable names. So we need a builder, right? Because that's gonna be our browser. We need to find things by, right? Key and until, those are the standard. So now we've defined the require statement. And then we want to build an actual method. So we're going to wrap it in parentheses because that's what we've got to do in JavaScript. And then we're going to do something. So we're using async. Let's call it the ping test. Okay, so I've started us off. Async function ping test, and we want to begin our work together. So what's the first thing we need to do when we are building a WebDriver test? Well, now we have the package required. We have the opening of an async function, but what are we missing?
The website we're going to test.
Yes, we're missing the website we're going to test, but we're missing even a step before that. We have not yet instantiated something that's going to enable us to go to the website that we're going to test. Right? We need a new builder. We need a new builder, which is the base element of Selenium WebDriver. We need a new builder, and we need it for the browser. Which browser are we using particularly? We're using Chrome, and we want to build that instance of the browser. So we invoking several methods here. We're chaining together. We are awaiting a new builder. We are then telling it it's for a browser or a Chrome browser, and then we're chaining onto it also that we want to build it, right? So now we have the driver, and Aris, you are exactly right. The next thing we need to do there is we need to actually get the website. Now, this is as simple as this. That's to get the website, right? Let me just paste this. That's to get the website, but what are we missing to get the website? Like, what will this give us back?
Is it like a capture of the website?
Almost. But what are we missing? Because we are in an async await pattern, which tells us where we're going to get a promise, right? So what do we need in front of the driver.get?
Then, or an async, yeah.
An await.
Yeah.
We need an await.
Yeah. Sorry, I'm old school.
Oh, it's totally fine. I don't primarily code in JavaScript. I mostly work in Ruby and Python. So I'm reminding myself this all the time as I'm building in JavaScript. So await, right? So we have the async. We start on line 7 async. On line 10, we are waiting for what are we waiting for? For the promise of this to be resolved, right? So this will give us an entire tree of the DOM. If we would inspect the results of this, we would get back all of the HTML for that site. And that site, what does it look like? If we go back, this site right here, it will give us back this site. but in just the HTML of it.
Is it possible to copy paste that URL for
Oh,
people to type it in?
of
I'm
course
typing
it-
what you are typing at the moment.
Yes, of course. In the chat, Aris?
Yeah, put it in the chat so they can copy paste the code that you are
Yes,
writing.
I did already. I'll do it again.
Well, what I did, I cloned your repo, and I'm just copying what you are doing on the screen.
Amazing.
Yeah.
Amazing. Okay, so that's the website. So now we want an instance of the website, but getting the website itself, that may be enough, but we actually want to change something onto this because we want to, if we just do this, and this would be the end of the method, the end of the function, I should say, and we would run this, we would see the website pop up on our browser, and then we would see it close. So in fact, let's see if that actually works. Let's do that. So let's actually run this. So I'm going to go back to my terminal. I'm here. You're not going to see what I'm typing because it's really small, but it doesn't really matter. It's not what I want to show you anyways. I'm going to run this. So this is in the test folder, and this is ping test. Let's see if it works. Right. You don't see anything, right? So you don't see anything. It doesn't actually tell us anything. It's not helpful and instructive in that way. Oh, you know why it doesn't run? Because I forgot to actually declare it to run. Those open and close parentheses at the end always get me. Okay, let's try again. There we go. We're opening a browser. You see the browser is opened. It says Chrome is being controlled by automatic test software. And it's loaded the website, right? Do you see that, Aris? Or Isabel or Edmar? It's not actually doing anything on the website, and it hasn't closed the website. So I'm going to close it for us. Let's just actually close it. Great. So we open the website, but that doesn't help us as much. We want to do something more. So we're going to chain a then onto this. Then we want to do something else. What do we want to do? We want to know if the website loaded, right? Because the website loaded, which means the ping test is working correctly. But if I'm automating this, the function of this is to automate the monitoring. So I don't need to go to the website and check it every 15 minutes. I want at least console log somewhere that, like, let's say this site is running. Woo, you know, this site is running. That's awesome, right? And if it's not, which is already helpful. So if we ran that, but actually before we do that, let's also driver.quit. So we close it. Okay, so now let's run this again. Amazing. Do you see that, everyone? Let me actually make that bigger because that's important. So in my terminal, you see it says right here, this site is running, right? And the line 14 of the code, await driver.quit, worked in the sense that the browser instance closed itself as soon as it was done. And now I have something functional that actually helps me in output in a log. You can imagine we're console logging this. We could output this to a log file. We could do anything we want with it. We could send it as an SMS message. I don't know if anyone would want that every 15 minutes, but we could, or 10 minutes or whatever, but we could do anything we want with this. In this case, we're console logging it for our purposes, which is great. So that's the success path. But there's more than a success path. There's also when it's not working. We want to be able to do something with that. And in JavaScript, you can you have thens, which is chaining a next thing onto it. And you also have catches, right? When an error happens. Let's catch an error. So let's say we want to catch an error. We'll use the E as the variable name. And what do we want to do if we caught an error? Well, let's do something similar. Ugh, that helper is not so helpful. Okay, so let's say there was an error. And we want to print out whatever the error was. Error.name, let's say. So let's say right now we're going to this website. Let's just change the website so it doesn't work. Let's change it to localhost. Why? Because I have nothing local running. So it should error, right? Let's run it again. Look at that. There was an error, WebDriver error. That is not the most helpful of errors. It does tell us there's an error, but we can actually drill down further and get more specific errors. But at least that's a starting point. Let's put that back to what we wanted at. Okay, let's run this again with the proper website. And we see it works perfectly. Awesome. That, my friends, is a ping test right here from line 5 to line 17. That would do that work for you. That would check that your website is actually up and monitoring its uptime for you. And you could set that on a cron schedule, for example, either on your own machine, on a server, using GitHub Actions, using whatever you would like, and have output to somewhere that's useful, maybe not console logging, maybe somewhere else. But that in those few lines of JavaScript is a ping test, which is really, really cool. Now, we talked about how we can make this headless, right? And headless means that it's not going to open a browser window, which we have now seen happen a couple of times. Let's change this a little bit. So over here, we have driver, right? And we don't define any options here at all. We're going to do something a little bit different. What we're going to do is we're going to actually break these things out. So let's get rid of this line. And we're going to have a Chrome equal something and a driver, oops, not two T's, a driver equals something. So the Chrome, as we talked about, we're going to require Selenium WebDriver Chrome, beautiful. And then the driver now await a new builder. And what we want to do actually is start breaking out the defaults. We're not going to be implicit in defaults. We're going to define them. So we're going to say it's for the browser. It's for Chrome. Beautiful. And we want to set some Chrome options, which means we need new Chrome. This is why we defined an instance of the Chrome driver so that we can do this, right? Using the options functionality within it. New Chrome options. And we're going to add some arguments. And the only argument we want to add to the options for this case is -- headless. And lastly, like we had to before, we build it. And that's it. And now when I run this, I should not see anything pop up. No Chrome browser. I should just see the output. Magic. It worked like magic. So that's how you define headless browsing. And under arguments for options, you can actually add a lot more as well. But headless is a very important one in the case of monitoring test suites when you want to automate them and put them on somewhere where you don't necessarily have access to a graphical representation of a browser. Hello, Muhad. Welcome. So glad you are here and joining us. So we have built the first one. And the first one, if you recall, is the ping test. We have completed the challenge. We have outputted a success message if it's alive, and we have also output an error message if it's not. We did it together. You all were amazing and wonderful. It's show and tell time. We don't need that because we didn't break out into groups, but that was the code that we actually built. And we did even a little more on top of that. We added headless browsing option as well to the arguments when we defined explicitly the Chrome options and didn't leave it to the defaults. Our third challenge, so the first challenge was getting our machine set up. Our third challenge is going to be checking the SSL certificate. Now, why is checking an SSL certificate important when you're thinking about synthetics monitoring? Why would you need to or want to do that? Any ideas, anyone? Isabel, Aris, Muhad, Edmar, any ideas why you might want to check regularly that your SSL certificate is valuable and valid, not viable, valid? Why is that valuable to do that?
I do have seen websites that the SSL certificates have expired, and I'm in some really major websites actually, and they're still expired, but because you don't constantly check when it's going to expire. If it expires, it's not only the website that is not running, but if you have some images that you are using somewhere else, let's say it is a CDN, then those images will stop working on the other website as well. So it's not.
Yes, that's exactly why. that there's a couple of reasons, Iris, and you actually enumerated a couple of them. One is, well, there's several reasons. One is your SSL certificate can become invalid in a way that you may never know unless you check. Depending on how you've configured your monitoring of your SSL certificate, which is, assuming you haven't because we're building this, you actually may never know until you physically go to the site that your SSL certificate is invalid. And what does that mean for your users? Having an invalid SSL certificate is a big point of concern from user accessibility to your site and confidence and trust in your site. If you are doing anything around commerce, transacting personal information of anyone, not having a valid SSL certificate is a great way for users to navigate away from your website and not stay with you, because modern browsers will actually notify them, alert, this website has an invalid or an expired SSL certificate. So that's one. The second thing, as you said, a lot of dependencies you may be using for image caching, like CDNs or things like that, may depend on you having a valid SSL certificate. And when yours becomes invalid, it's a chain causal effect where suddenly those things no longer work for you. And images are not rendering correctly, or other assets are not rendering correctly, and your whole website is no longer functioning. So building an SSL certificate monitoring synthetic test is quite essential for the health and performance of your website. So in this challenge, what we want to do is we want to output a success message if it's valid with accompanying data from the SSL certificate. And we want to output an error message if it's not. The hint in this case is you will need an external dependency to do this. Which is very important, because Selenium WebDriver on its own is not able to check the SSL certificate validity from the browser when it's navigating there. So you need an external dependency. And thankfully for us, there are actually quite a few external dependencies out there. So let's actually go, let's see here. I will show you this browser window in a minute. I'm loading the page. I'm starting to bring it in there. It's a little big, I know. Let me get that looking correctly. Okay, so we're looking at npm.js, right? And you see that. If I just search for like SSL, SSL check, SSL expiry, keep an eye on the expiry dates of SSL certificates, SSL date checker library to check and report on the start and expiration date of a given SSL certificate for a given domain. So you can imagine, even not even looking at the code for this, but you could have a little bit of functionality, a little logic where you know the current date and you check the expiration date and you do a bit of math to figure out if your expiration date is past the current date, and then you have a problem, right? Certificate monitor, utility to check on SSL TLS certificates. There is a lot of SSL packages within Node. Buyer beware, right? With all things and external dependencies, I advise you to check them thoroughly to make sure you know what you're getting into. If it's preferably use something that's open source where you can review the code and check every update. Don't just blindly install the latest update for that package, but check to see what was updated in it, do some diffs. But there's a lot. The one that we are going to use for our case is SSL checker. Exact match. I love npm.js. It's getting so awesome. So we're going to use this one. And you see, for example, get SSL details, async, host name is a string, right? Await SSL checker, host name, and then you pass in the website domain. And you see the response example here is JSON, and it comes back with one of the attributes is valid, and it's a Boolean of either true or false. So that is a simple way of checking for us relatively for our needs. So we're going to use that. Oops. Minimize this for a second. Okay. Let me get back there. SSL test. So we're not using Selenium WebDriver in this case because it's not possible to use Selenium WebDriver to check the SSL certificate's validity. We're using this external package called SSL checker. So how might we do that? First, we need to require it. We're going to require it. Okay, we required it. And if we go back to looking at the examples, we see, well, we see you could just, it takes an argument of just you don't need to define host name as the parameter. That's the default parameter. So you can just pass in the string containing the host name. You could also, if you want to, otherwise this is default, pass in the method, but we're using get as a method or HTTP verb. And then we can chain a then onto it to do something with it, right? Very cool. So what we want to do, I keep going back to the wrong place. Let's minimize this. What we want to do is do something like that. So SSL checker, google.com, not google.com. What are we checking? We are checking our website. So if we paste that back in here again, there we go. Beautiful. So that's the website we're checking. And let's give it the verb. Why not? And we want to then, of course, output the result. Let's just take a look at what's in the result. Let's run this. Let's see what happens. We have an error. Seems like there's some async issue here.
The domain is correct.
Say it again.
Is it that domain is correct?
Yes, that domain is correct. Yes. But maybe let's get off the this. Let's just try it. Oh, there we go. It was unnecessary. It was throwing an error for that. So, and just printing out the results gives us this following object, right? Days remaining for the SL certificate 61. It is it is valid. It's valid from February 22nd until May 23rd. And it's valid for anything on render.com and any subdomain of onrender.com. So it is a valid SSL certificate. So now we know that.
It's by Cloudflare.
Say it again.
Is it by Cloudflare?
It is by it is by onrender. I actually don't know. It's probably Cloudflare, I imagine. Onrender.com. Muhat, have you heard of it before?
Sorry, actually we can see the onrender.com in hosted via Cloudflare. So we can show that domain from Cloudflare itself.
Yes, what we're doing is building a little bit of a monitoring test suite to check for the SSL validity through our code, but yes, that is correct. So if we remember, our challenge is to output a success message if it was, let me go back, if it's valid with accompanying data, and output an error message if it's not. So we know the result holds valid, that's a Boolean, that's gonna be very helpful for us. That's really all we need. So we can then result, right? What do we want to do here? How do we change this code to either be catching an error or just putting the results? So let's say then, what do we want to do? How are we going to change this, folks, to meet those needs? The needs are, once again, output a success message if it's valid, or output an error message if it's not valid. Well, let's try this. So it should look familiar because we just did this last time. That's, I think, getting us on the way. Right? That's helping us. But we actually need the logic to be a little different because this will always output here if whether it's false or true. So we need to just change the logic a little bit. So how we change the logic? What we want to do is if it's true, if it's true, output this. If it's not true, output an error that it's not true if it's false. How might we do that?
You couldn't able to get the result there.
Say it one more time, Mohat. I can't hear you. Sorry.
You couldn't able to get the result variable there
Yes. Okay.
on catch. So you can put it the false value means there in code or the string as a string, maybe. I think that's the same error object,
That's what I thought.
not the
Okay.
result.
I'm just following what you're saying. Tell me where to put it.
No, you couldn't able to do that same.
Okay. So
You
tell
want
me,
to make it as a string, false or something.
right. So what we want to do is, oh, I see what you're saying. Got it.
You may want to put the await syntax before that thing and or think await.
You're right.
Sorry, I don't want to interrupt.
No, this is what I'm intentionally not doing it all the way through. I'm hoping people interrupt me. So Muhad, you're doing exactly right.
Okay, no issues. You can put like await note there before the SSL check.
Perfect.
You want to when you want to write the await syntax, you want to within a async function you only call the await. So you want to make it as a function. All things in a function, and you call it like all things within a async function.
No? I think I put it in the wrong order. This always catches me in JavaScript, my friends. No, that's the right order. What am I doing wrong, people? Okay, we'll get to the back of this later. I'm missing the first bracket. Where? Line 6.
There is
Oh.
yeah.
Ay. Okay.
I think you do it in purpose so we can you can see if we follow up. That's a joke.
I'm missing the first bracket. Where's the bracket?
The curly bracket after the
Here on-
SSL checker.
It's here on line 5.
Yeah, but the SSL checker, I think you're putting an object. So after that parenthesis, you need no? Oh, wait. Oh, wait, remove the number 9.
This is basic JavaScript, my friends. We are live in basic JavaScript, figuring it out together. It is awesome. So is always business closing parameter. Wait. Edmar, you are a brilliant person. You should just know that. That's exactly what was happening there. Perfect. 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 Everyone, the win is for Edmar. He gets the win. He gets the extra brownies today, the extra chocolate chip cookies, whatever you prefer. Okay, so this should give us, this function should return us the Boolean eval of true or false. I think we can assign this to the variable, right? Does that works, right? And then if result is true, let's just see what happens. Well, that doesn't make sense because we know the site is valid. Maybe. Okay. It is the function. Wait. Undefined, because it's the function itself. Got it. That's the issue. I think it's because does that work? No. Okay, my JavaScript friends, how do we resolve this? Oh, maybe just that. Nope.
What is the error you're getting?
Well, the result of result is the actual function. You see that? I'm highlighting it here.
Where do you console log that?
I console logged it here because it's outputting right now the else part of the logic tree.
Okay, so let's put a console log in the on line 11 for a console log on the results. We can see what we're Oh, can we get a full object so we can see what that gives us? It is
It's a
quite
promise.
basic.
It's a promise.
Okay, so the promise hasn't been resolved.
Hasn't been resolved. Should we put a bit of a sleep?
So you have an SSL check. That's the functions async. And then where's the result coming? It's that function. The result comes from that function. Why don't you put that line from line 14 to line, oh, wait a second. No, don't
I
do
think maybe
anything.
you should put like a sleep. Can we?
Okay, so async function. Okay. Oh, I think there is okay. Let's do it with the result being result dot then.
Aha.
Let's write. Let's do yeah, no, not there. Line 12. Remove a console log and do press enter after line. Okay. And again enter result dot then result dot then and then parentheses like running a function. Yep. And then put what we are waiting. It's like an object, so that will have the valid inside, right? No, but that valid is you need to destructure it. So you need to put it in a way that we can get the valid from that object that it will return the valid, and then you can run the if else inside that then. No, not there. So just keep it there, valid. Put an arrow after the second parent, after the. Oh yeah, do it right. Yeah, response. Yeah, that's good. Inside the curly brackets, put that if response dot valid and stuff. Can you do it there? Respond instead of result, put it respond. Can we try that?
Let's see what happens. Undefined.
Put a question mark. No. How does it not? How does it become undefined?
This is totally live, my friends. We are figuring this out together. The wonders of coding.
How can we debug it if we so we can see?
There's no return on the inner SSL checker. There's no return on the inner SSL checker in here, right, Edmar? What you're referring to?
Yeah, just you can put arrow functions there. Just remove the parenthesis on the fifth line.
On the fifth line?
No, the fifth line, the open parenthesis. First fifth line, line fifth. Remove that open braces and put a arrow function there. Yeah, that's and remove. Sorry, you don't want to put that thing. So there is a function. So you sorry, you don't want to put the arrow function. Sorry, you don't want to put the arrow function. Just return on before the await. Sixth line before the await, you can just put on the return key. Remove the okay. That's okay. Then return add the return statement before the await.
Aha.
Yeah. Okay. That's okay.
Haha. Muhad,
Sorry, I have some network issues there, so I went out.
Both are brilliant JavaScript developers. Any company
Yeah,
looking to
actually-
hire a JavaScript dev, Edmar and
Sorry.
Muhammad are your men, are your
Yeah,
people.
actually, I'm working as a tech lead in here in India.
Well, there you go.
Mhm.
This Ruby and Python developer who's giving a workshop in JavaScript needed your help, and I'm very grateful.
Okay,
There we go. Awesome.
we
So
can-
now we have turned this into, we've met the parameters of our challenge. We've output a success message if it's valid with accompanying data from the SL certificate, and we'd output an error message if it is not. There was a lot of internal JavaScript work there, but we accomplished it. You should all feel very proud of yourselves. We worked it live online in the moment, and we got it done. Okay, moving on to our fourth challenge. Our fourth challenge is checking if all the links in the page are valid. So once again, the website we're looking at is, let me show you the website. This is our website, Meet the Minions. And each of these links, each of these things are a link. So this links us to Bob. This will link us to Kevin. And onwards and onward, this is Stuart, etc. So we have 4 links, plus we have a subscribe link, which doesn't do much validation on it, but checks that you clicked it and gives you a valid thank you message. So we have a bunch of links. What we want to do is we want to check that each of these are valid. So now we're going to iterate through the links and make sure that that every link is working. So that's our next test. This one, I believe, will be a little less complicated because we're not using external dependency. We are just using Selenium WebDriver, which thankfully abstracts a lot of that for you. So once again, we are going to define what we need. And we're going to open up an async function. And we're going to start going. So just like before, let's first, we are going to just do exactly what we were doing before. So let's take the link. This looks very similar to all the other ones we're building because the pattern keeps on repeating itself over and over again. So we put the URL in here in a variable. We create a new driver. We instantiate a new instance of the builder. We have the driver, and then we are going to try all the links, and we're going to see what happens. So if you remember, when we use find elements, there's 2 methods that are very handy to find things on DOM. Using Selenium WebDriver, you can either find element or find elements. Find elements in the plural gives you an array, gives you a list of all the elements that it found. That is exactly what we are going to do. So we are going to try that. We're going to get the URL. And then we are going to get all the links on the page. Now, if you remember how we get links, we use the find elements. And we want to find it by something. In this case, we're going to find it by the tag name. All the arefs, all the links. Beautiful. And now we want to iterate through those links. So we'll create an iterator. This should look familiar to most of you. this is important as well. We want to wait. We talked about this earlier, wait until the DOM is resolved. And then the element is located. What element are we looking for? The element that has the tag of an A. And we're going to give it some time to wait. So let's say we give it, I don't know, 30,000 milliseconds. Let's take some slow time there. I know we're repeating ourselves from line 12 to line 17. It's okay. We're building an example here. And then driver dot find the elements. And then now we have all the links. We have all the links. So now what we want to do is iterate through each link. So each link would be changing, right? We're going to go through each link in the list of links. Await driver dot get. Await link equals await links, that item in the array. We're going to get the attribute, which is the link of that link where it's pointing to. And then we are going to get that link, the sublink, the nested link. And we are going to console log something. And if it fails, we want to also catch the error. And we'll console log that. So if we walk through this, first on line 12, this is probably not the cleanest way to do it, but this way accomplished it for us for our purposes. We're using this to define the length of how many links there are for our iterator. So we're getting the links first. That's probably not the most performant way to do it, but we're doing it. We're getting the links first, and then we're using that to define the length of how many links there are to create an iterator, right, on line 14. Then we get the website. We once again get the links, although we probably could just use it from here, but we have another time. We go through each link in the array of links and get the actual website it's pointing to. We then navigate to that link using .get. If it responds, if it loads, we console log it's alive. If it's not, we console log there was an error with the name of the error. So that should work. Let's see what happens. It's getting every link, and you see it's loading multiple times. And I did that on purpose because the website itself has multiple links. So these little tiny social links on the bottom of each minion are linking to the same site for each of them. So, you know, if this is Bob, it's linking to Bob. So that links to Bob. This links to Bob, etc., which is why you saw in the browser that it kept on loading Bob multiple times because it was going through every single link. And if we look at the console, what we see is every single link is actually working. That's a page crawler. Any questions there? That was a bit easier than the SSL checker because Selenium WebDriver, the amazing thing about it is it takes care and abstracts a lot of that out for you. You don't need to worry about all those fine details of navigating the promises and catching them in all those ways, because it's taking care of it for you. Our last challenge for our time is we are going to fill out a form. Remember, there was a subscribe form at the top. We're going to fill that out. So we're going to verify that the success page loads after the form submission. This, again, will look very familiar. You should be becoming experts now building your own. So we need to build a submit form test, something that's going to reach, basically hit enter on that form. So we are once again going to, let's just copy that out of here. There we go. Okay, so what we're going to do is create another async function, call a form test. Once again, we want a URL. Let's grab the URL. What else do we need at this point? What am I missing? You all know the driver. How do we build the driver? We need to create an instance of what? The builder. The builder for what browser? For Chrome. And we want to, of course, build it. And now we are going to fill out a form. We're going to load the website. And then we want to wait until the website is rendered fully and the input text box is there. That's very important. So until the element is, remember it was element located, and we want to find it by its CSS. And in this case, it's an input. And let's give it some time to do that. So now we have wait until the element's there. We want to grab the form. So similar to above, now that we know that it's there, we can then find it. If we did this line 14 before the DOM was fully rendered, what would happen is this would be, it would not find it. It would error out that it wasn't there on the page because the script is sometimes running faster than the website actually loads. So the wait on line 12 is essential. So now that we know it's there, we can find it. We find it again, similar to CSS of input. I think I put that in the wrong spot. There we go. Now we have the form. If you remember from the example earlier, we can send keys. So we can put an email address, we can say my email at cityjs is awesome.com. And then we could also send the return key. And we got to again wait until what? Until the next page loads, the success page. So similarly, until element is located by CSS, we're going to look for an H2. And we'll give that, some time. And then we want to grab the title from that H2. So wait driver.find element by CSS H2, and we want to get the text. Oops. Not the tag name, the text. And then just some simple logic here. If the title equals thank you, then console log successfully submitted the form. Else form is not working. And then lastly, we always, as a matter of good practice, want to close the browser session, the WebDriver, and not let it hang and sit there. So this should work. Let's run this. What is this one? It's called form test, submit form. You know what I forgot? I forgot to actually invoke the method. And we saw it happen. Beautiful. We did it. Muhad, actually all of the code for this is on a repo. You can, I shared in the beginning. I'm going to paste it again here for you. It's right there. So if you go to that workshop repo, under the examples folder is the working code. The test folder is everything is empty in there. We're filling it out together now. Yeah, my pleasure. Okay, so what we saw here was, again, what we're talking about is a very similar pattern of using Selenium WebDriver. We could do different things with a pattern and accomplish different tasks. But the pattern remains the same. We're using an async await pattern. We're instantiating a driver based on the builder. We're assigning it to a browser instance of, in this case, Chrome. We wait for the URL. We wait for things to get resolved, which means we wait until the element is located before we try to find the element. That's very important. That is often one of the biggest mistakes people who are new to synthetics make. They try and find something before it's there because their script, as I said, is running faster in most cases than the website is loading. And then we do some checks to make sure things are what we expect them to be. The last thing I want to share with you is automating this with GitHub Actions. So you can do this and run these scripts on your own computer and your own machine and create a cron schedule on your machine. You can run on your server. You can also use GitHub, which offers free runtime through GitHub Actions to do this for you. So I'm gonna, instead of building this together, I'm actually just gonna show you because it's a bit faster. And the result of what you do with GitHub Actions is you'll have a YAML file. So now we've left JavaScript. Now we're in YAML. You have a YAML file. Let me actually show you in GitHub itself. Let's see here. Right. Okay, let me make this bigger. And what's really cool about actions, so all actions from the interface of github.com can be their runtime behavior, their actual runs can be found under this actions tab. Right? And you click on the actions tab and you see all your workflows here on the left-hand side. And then you click through to any specific workflow. So here's a workflow for running the synthetic ping test, which was the first test we built all the way in the beginning of our time together. And you see the green check mark tells you that it was successful. If it wasn't successful, there'd be an X, a red X. And we can actually click through and see the results of this successful run. We see that it set up the job. Meaning creating the virtual environment using Ubuntu. It checked out the repository, this repository, and cloned it into this virtual environment. It's using Node.js. It is installing the packages within the package.json, and it is running the script. And Node examples, ping test, right? The site is alive. It's outputting it for us. And then it does a cleanup at the end to make sure I close the virtual environment, cleans up all the cache, etc. Where does this come from in your repository? So this comes from this folder, .github/workflows. Every workflow you want to run on GitHub needs to live in .github/workflows, and it is a YAML file. And this YAML file is 19 lines. Starting with the name. So the name we saw in the workflow, this dashboard, synthetic ping test, comes from line 1, where then I assign the name synthetic ping test. You have to define when you want this to run. And there are all sorts of parameters you can define. I, in this one, only defined workflow dispatch. Workflow dispatch is actually super neat. And I want to show you what that means before we walk through the rest of it. What workflow dispatch means is I can go into my workflow, and you see over here where it says run workflow with a dropdown. I can literally run the workflow whenever I want to run that workflow. So I just come into github.com, my browser. I can choose to run it from whichever branch I want to run it from. In this case, this repo only has one branch, and I can run the workflow. That's amazing. There's you can schedule the ons to be based on a pull request, based on a successful mergeable pull request, on a new comment, on a new issue, on anything. You can really define on anything like that. You can define it on a cron schedule, and it takes the scheduler cron syntax. So you could say, I want this workflow to run on Mondays, Wednesdays, and Fridays at 12 a.m. Every 3 days, or you can say, I want this to run every 5 minutes, 7 days a week, whatever you want. And all that syntax exists actually on the GitHub Actions docs. And then you have the steps. In this case, we have what we call the jobs, right? And each step is here. So first we have to define the build. We're building this on a virtual machine using Ubuntu. You can also run this on Mac OS or Windows or whatever you want, whatever virtual machines GitHub provides you. And then you have steps for the workflow. So each of these defines a new step, each of these dashes. So the first step is we are checking out the repo and cloning it into our virtual machine. The second step, we give it a name, and we're using Node.js, and we use this action. So you can use other actions inside an action. So we're using this action called setup node to create the node environment in our virtual machine using node version 17, and we're caching npm. Then we've defined another step, and we called it install packages. And that's where we just run npm install. And lastly, we have another step that we call run script. And there we run the actual script using node examples ping test headless.js. So you can do that in GitHub Actions and create your own synthetics monitoring suite using the free runtime that GitHub Actions provides you on all free public repos. If I'm not mistaken, GitHub only provides the free runtime on public repos, not on private repos. These need to be public and open source. With that limitation, though, it's an amazing tool and there for your resource. So if you use it, what you get is the ability to basically see your builds, run through them. You can even include like an API call to something that could send you an SMS message on a successful run, or maybe more importantly, it could page you an SMS message when it's unsuccessful. And so that can all actually happen also in GitHub Actions. Provide your secrets there so you can access APIs with credentials. It is a fantastic tool. We have accomplished a lot in our time together. We have walked through many, many different suite utilities for synthetic monitoring test suite. We have built all different kinds of them. We kind of got stuck in the weeds of JavaScript syntax a little bit, which is wonderful and cool and important. And I thank you for your time. If there's any more questions, now is the time for them. And I do also want to remind you that if you visit City.js, the website, and click on competitions, down there is a link to this, and that's the link directly, where you can sign up to get posted to your address, your physical address, a box of swag from New Relic, an awesome box of swag, socks and shirts and stickers, all kinds of cool stuff, and also 100 gigs of free data ingest on your already free New Relic account. So if you're doing synthetics testing and you want to use the automated synthetics monitoring that New Relic offers, 100 gigs is quite a lot to get you up and running. So make sure to go there, sign up, get the swag box, get the 100 gigs of data ingest. It's well worth it. And I thank you for your time. Any last questions, my friends? Awesome. Well, thank you all very, very much.
So much. It was super, super helpful. Thank you.
I am so glad. Isabel, it was so nice to have you here. And Muhad, you have been amazing. Edmar, you were fantastic. You are all my champions. You are amazing people. This has been great. And I hope to see some of you in London on Friday if you're local.
Okay, thank you.
Thank you, Aris, for inviting me.
Thank you.
Thank you, everyone. Have a wonderful rest of your day.